Okay, so 5.4 graphs of sine and cosine. So we did a little preview of this in class. So we're going to start first with general form. So that's not general form. General form is like this. Why would we have to do that? Because we want the x to be all by itself. We want to factor out whatever number's in front of the x, right? So just like normal, if it was like 2x minus 6, factor out the 2, and then we'd get like in parentheses x minus 3 or whatever, okay? So we're going to write it like this as general form. So this is for sine and cosine. Okay, so these represent, some things are going to seem really familiar and some things are just going to have a different name or they're going to be a little bit different, okay? But most of these are the same thing. So this we know as a vertical stretch, right? So if you cover everything up, that's y equals, and then it's some number. So that's a vertical stretch or vertical compression. But we're saying that this has a new name when we're talking about, I know, a new name, it's crazy. When we're talking about sine and cosine graphs, it's called an amplitude. So when we talk about sine waves and cosine waves, it has a lot to do with like physics and sound waves and things like that, microwaves. These are all sine and cosine waves, okay? So they have an amplitude. An amplitude is how high or low they go. So the amplitude is the absolute value. So amplitude is always positive. So if amplitude is -2, or sorry, if this is -2, amplitude is +2. So it just tells you go up 2 and you go down 2, okay, from the middle, wherever the middle is. Okay, that helps you get what we call a period. So I know that usually we do, I'm going to go like that, so skinny versus wide, okay? I'll just show it, it's fine. So that's skinny versus wide. So a period is going to be 2 pi divided by b. How come it's 2 pi divided by that number? Because 2 pi is 1 revolution. So if you take 1 revolution, usually this number is 1. So when you take 1 revolution, you're going 2 pi radians. So that's what we want, okay? So normally, if this number is 1, like what's the graph of sine of x? It's like how we graphed it in class. So it'd be 2 pi is our period. 1 period is from start to finish. What does it look like? So from start to finish, if it starts here, it would finish here. So 1 revolution from wherever we start to wherever it ends up in that place again. That's 1 period. Okay, so that kind of tells you how skinny or wide it's going to be, but on a graphing calculator, you can tell how skinny or wide or something is. So you can put this into a graphing calculator and y sub 1, it's possible, and you'll see if it's really skinny or a little wide or whatever. But when we graph it, it's all going to look the same. You won't be able to tell, so I'll tell you how we graph it, okay? This is still your horizontal shift. This is still your vertical shift. So notice you're dividing, right? So if that was like a 2 and that was a 6, you'd be dividing and you get a 3. So even though that's a fraction, I just had to make it a fraction so you can tell what's going on, okay? Same thing holds true for cosine. So sine and cosine, it's graphed almost the same, you know, kind of like what we did in class. They look almost the same. Okay, you guys know this is increasing from left to right. We're increasing, we're decreasing, we're going to increase, decrease, increase, decrease. It's a wave, so it keeps going and going and going. Okay, so these are the steps, and then we're going to, I'll just show you. So the first one, remember what we did in class? So generally, this is how we graph sine waves. But we're not going to do this every time. We're doing this one time. I did it with you guys. How did I get these numbers? I looked on the unit circle. So from start to 1 revolution, from 0 to 2 pi, you look at the unit circle. Actually, you know the unit circle. What is the sine of 0? It's 0. What is the sine of pi over 2? So 90 degrees. The sine value, the y value is 1 on the unit circle. So that's how we got these numbers. And then we graph it. So when you graph it, you're going to go 1, 2, 3, 4, and that's always going to be 1 period. We're always, you're going to write this down, you're always making 1 period, 4 units. You have to use a graph that looks like this, okay? I know, it's really mean. You have to use a graph that looks like this. You're going to copy mine, or you're going to print mine, or you're just going to use your own graph paper, but you're going to go 5 by 5, okay? So 5, 5, 5, 5. All right, so when we graph it, we're graphing like 1, 2, 3, 4, above, below, and then this is going to be pi over 2, pi, 3 pi over 2, 2 pi. In general, because whatever our period is, we're going to go ahead and write this. How do we know what our period is? It's 2 pi over b. b is 1, so 2 pi over 1 is 2 pi. So 4, counted out, 4 units is 2 pi, and then I go halfway for pi. And then when I graph this, it looks something like that, okay? So what do all these other things mean? There's no horizontal shift, there's no vertical shift. You can tell for the domain, it just continues. You're always gonna go all the way from the left to the right. You're gonna make a little arrow, you're gonna make a little arrow. Here's what I do not want you to do. I don't want you to go down and keep going down and make an arrow. That's not true, right? Because it goes down to here and then it goes up and then it goes down and then it goes up. So do not make an arrow coming down this way. So there should be no arrow going down here. There should be no arrow going up this way. It comes back down and then you make an arrow. So it repeats and repeats and repeats, and it does not go above 1 and it does not go below -1, okay? Your range, you can tell in the picture, is from -1 to 1. Okay, this means vertical asymptote. You're not going to have any vertical asymptotes yet. And this means, is it flipped? Is it flipped upside down? When would it be flipped upside down? When there's a negative in front. So right now there's no flip. So you can put none or just, whatever. Okay, so this is what a sine graph looks like. So now we're going to graph this one. So our first steps here are going to be, what is the amplitude? What is the period? What is our fake origin? That's what we care about, okay? So the amplitude is 2. The period is going to be 2 pi over 1. And then we have a fake origin. We're going to list all of those things. And then don't worry about the domain and range for now, but we're going to list those at least, okay? So I say this is my fake origin because it's, I go to the right and then I go up. So pi comma 1. Okay, what is my period? My period is 2. That's where I start my graph, guys. So I start 1, 2, 3, 4. I start here and I put 2 pi. And then I go here and I put pi. Why do I put 2 pi here? Because that's my period. Why is that my period? Because my period is 2 pi over b. b is 1. Okay? So I start my period, and then I label this, and then I label my numbers up and down. So at least one number. You got to label at least one number. And then here's what I do. So from my fake origin, I go to my fake origin. So that's pi comma 1. After I put my numbers in my xy axis, I go to pi comma 1 and I put an x. That's my fake origin. I also highlighted it, but I put a little x. That's my origin. And then what do sine graphs do? Usually they go to the right and up 1. What is this going to do? It's going to go to the right and up 2 because it has an amplitude of 2. So it goes to the right and up 2. And then usually it goes to the right and down 1. So I go to the right and down 2. And then what's it do? It goes to the right and goes down 1. So I go to the right and go down 2. Okay, I follow these all the way to the other side. And it's always going to be like repetitive. Okay, it's not going to be skinny one place and fat the next. Okay. And then now I have my graph and I can see, so if I start here and I follow this, because I know sine graphs do this, they go to the right and up 1 usually. But now I'm going to the right and up 2. Okay, so then now I can look at this. I go, what's my domain? It's all real numbers. What's my range? Looking at this graph, I can see my range is from here to here, which is from -1 to +3. Again, my period is those 4 units, always, always. That's how I start. I start by doing my period, by doing this number first. Okay, let's try another. So, for the next one, so the first thing you're going to have to do is factor out that 2. So be careful, you want to factor out that 2. What is your amplitude? It's +3. What is your period? It's 2 pi over 2. So your period is 2. Or sorry, it's 2 pi over 2. So your period is 1. Right? 2 pi over 2 divided, you get pi, 1 pi, 1 pi. Oh my gosh. Okay, so my notes are right. Okay, and then my fake origin is right there. I deal with that later. I'm going to go ahead and write this first. And then where do I start? On my graph, I start with my period. So I count out 4 units from the origin, from the real origin, I count out 4 units. And then I put not 2 pi, I put pi because that's my period. So I count out 4 units, I put pi, which means this is pi over 2. If I want to put pi over 4 here, I would do that. I just didn't, you know, because whatever. Okay, so I at least need these 2, and then I want my 1 and my 2 just in case. Okay, now that I have my x and my y coordinates, I'm going to use my fake origin, which is a negative pi over 2 comma negative 2. So negative pi over 2 would be, if this is pi over 2, negative 2 pi over 2 would be here, and then down 2. I put a little x. This is my fake origin. This is where my sine graph starts. And then again, what do sine graphs do? They go to the right and up 1. What is this sine graph going to do? It's going to go to the right and go up 3. And then it goes to the right and goes down 3. And then down 3 some more. And then up 3. And then up. And then I follow it all the way. I keep repeating all the way. This is what the sine graph looks like on a real graph, where this is 0, 0. I used my fake origin to start it because I know the start of the graph always tells me to go to the right and up 1 normally. Okay? Okay, now I look at it and my domain is still all real numbers. My range, once I graph it, I can see it's from -5 to +1. Okay, so that is sine. Cosine is almost exactly the same, okay? So, oops, sorry. So cosine, you know, we did this. We looked at our unit circle, and it looks like that. And we graph it the same way. We start with the period. Where's the period? Go halfway, just to label it. And then this is where this is what cosine looks like. I need to remember what cosine looks like, because later when I start, see how it doesn't start on the origin? It starts above the origin. So the first thing that happens is you go above the origin, and then you go to the right and down, point. To the right and down, point. Right and up, point. So it's going to look like this, and this is what I remember for all cosine graphs. Okay, so let's look at the first one. What are you going to do first? You're going to factor out the 2 because you're not a sucker. And then, what's your amplitude? 2. What's your period? 2 pi over 2, which is pi. So you have these things. You have your fake origin, which is negative pi over 2 comma negative 3. Okay, so I'm going to start with my period. I'm going to count 4 units and call it pi. So I count my 4 units, call it pi. I label this pi over 2. I label this 1 and 2. And then I go to my fake origin. So I use my fake origin, negative pi over 2, because this is pi over 2, so this has to be negative pi over 2, comma negative 3. This is my fake origin. What do I do from my origin? How do I draw a cosine graph? I start usually at 0, 1, so I start 1 above. Do I start 1 above here? No, I look at my amplitude. I start 2 above. So you start 2 above, and then normally what happens? You start here, and then you go down to the right. So I'm going to do the same thing. Instead of going to the right and down 1, I go to the right and down 2, because my amplitude was 2. I keep going, I keep going. So imagine this midline right here. There's a midline. That's where your x-axis is here, right? So this is my midline. So if I start here, I have to go underneath it, and then I go above it, underneath it. It's nice and smooth. You don't have V's, okay? This isn't like solid, this isn't a line. These are not lines. These are curves, okay? All right, once you do that, you can fill in your range, which is from -5 to -1. You can see it on the graph. So fill in your range afterwards. It's really hard to fill it in before. Okay, last one. So this is going to be crazy. Ready? So you have this. Ooh. You got to factor out the 1/2. Okay, 1/2. What's 2 divided by 1/2? Think about it. 2 divided by 1/2 is 4. because 2 divided by 1/2 is multiplying by the reciprocal, which is 4. Okay, what is your amplitude? Your amplitude is not -2. Your amplitude is 2. What is your period? Your period is 2 pi divided by 1/2. What's 2 pi divided by 1/2? It's 4 pi. So here's my amplitude. Here's my period. It comes from my formula, 2 pi divided by that number. And then this is going to give me my fake origin. Okay, so where do I start? I start with my period. I count out 4 units to the right, and then I write 4 pi. And then I go here, and then I go to half, so 2 pi. So I know that I'm going by pi, 2 pi, 3 pi, 4 pi. And then I number 1, 2. Okay, I start here as my fake origin. So I go to the left, 4 pi. So 1, 2, 3, 4 pi. And then positive 1 is going up 1. This is my fake origin. From my fake origin, what normally happens, again, what normally happens? I go up 1. Do I want to go up 1? I look at my amplitude. No, actually, I want to go, see right here, there's a negative. I want to go down 2. So instead of going up 1, this is -2, I go down 2. So this is how I start. This is my midline. This is actually the middle of my graph right here, where my fake origin is. At y equals 1 is my midline. And then instead of going down some more, and then back up, I'm going to go up some more, back down, back down. So remember, this is my midline. I have to go above it and below it. Okay? I follow it all the way. And then my domain is all real numbers. This one had a flip. You see that negative? So yes, that one had a flip. And then after I graph it, I can see, oh, my range is from here to here. So -1 to +3. So there you go. Okay. So for tomorrow's homework, you have to use graph paper. You can download my graph paper, which looks just like this, or you can use your own graph paper, that's fine, but you need a 5x5. I don't want you to draw it like skinny. I don't want you to draw it wide. I don't want you to draw it so that there's only one, quadrant showing. I want to see all 4 quadrants, and I want to see it where it's supposed to be. Okay, so 5 on each side. Okay, you don't have to box out 5 on each side, but it should be 5 on each side. That's like the least that you're going to graph, okay, if you're using your own graph paper. All right, I'll see you tomorrow, and we'll review this.